December 17th, 1903. That day was when the Wright brothers successfully invented the airplane. From that day on, aviation was never the same and became a fundamental mode of transportation for humans. On a daily basis, we have aircraft weighing 80,000 pounds flying 2.7 million passengers around the world. However, today, we want to answer the question of how these heavy aircrafts are able to lift off from the ground.
The secret behind the aircraft comes from the wings. We see in a plane wing that it is not completely flat at the top nor the bottom. Instead, many airplanes follow the design of having a curved surface at the top of the wing. This structure is called the airfoil. It is because of this that aircraft were able to produce lift. However, it would not be possible without Bernoulli's principle. Simply stated, the principle states that as the speed of a moving fluid increases, the pressure of said fluid will decrease. In terms of aviation, this fluid would simply be the air. As the plane flies, the wing's leading edge splits the air, forcing the air to flow above and below the wing at varying speeds. As we had said before, the wing's upper surface is curved so that the air rushing over it speeds up as it has to cover a greater distance, essentially stretching it out. In turn, the air pressure above the wing would decrease while the air pressure below the wing stays relatively the same. Since the air pressure at either side of the wing is now different, the higher pressure below the wing moves towards the lower pressure towards the top of the wing. Because of this, in about the middle of the wing, lift is produced by the force of the air perpendicular to the wing. Flight is then made possible when the force of this lift is greater than the force of gravity. However, it is important to keep in mind that this is not the only reason for flight.
Although the most common example of the Bernoulli principle is a lift seen in aircrafts, this principle has a wide range of applications. It can be used in things from engineering fluid dynamics to designing pipes for hydroelectric plants. A key device that utilizes this principle are perfume atomizers. Perfume atomizers are basically the handy little contraption that's responsible for turning the liquid perfume into a fine mist by mixing oxygen and the perfume itself. Since the air within a bottle of perfume will be moving relatively slow, it will have a great amount of pressure according to the principle. Within the bottle, there are two narrow tubes, one running up the bottle vertically, and a second one perpendicular to the first with a squeeze pump attached to it. This squeeze pump allows air to flow up quickly towards the top of the bottle, where the pressure is reduced. The perfume as well is drawn from an area of high pressure and gets ejected from the spray nozzle with the help of the squeeze pump.
To demonstrate the Bernoulli principle, we conducted a simple experiment that better presents the concepts we had talked about in this video. We created our own airfoil by folding a sheet of paper and set a piece of straw through a tilted hole near the front of the wing. We then added a vertical stabilizer, again made out of paper, so that it doesn't rotate when we set it in a wind current. After making the wing, we set a piece of string through the straw and set a blow dryer in front of the wing. By placing the blow dryer so that part of the air flows through the top and part of it flows through the bottom, we were able to produce lift on the wing. This is the reason as to why the wing is staying in place and not simply just falling down.